Hello and welcome. Today our task is to prove a trig identity. To show. Okay. So the root of 1 plus 2 cos b plus cos squared b all over sine 4b plus sine squared b. So let's focus on our numerator. I can write this as 1 plus 2 cos b can be written as cos b plus cos b, then plus my cos squared b, all divided by, now let's come to the denominator. There's a common factor here, which is sine squared b, so I'll factorize that out. So I have sine squared b, I'll be left with sine squared b, then plus cos squared b. So this should be equal to, now I have 4 terms, so I'm going to group them into 2. So still on my numerator, I have 1 as the common factor, then I have 1 plus cos b. The common factor here is cos b, then I have 1 plus cos b. That's my numerator. My denominator, you should be familiar with this identity. Sine squared b plus cos squared b should give us 1. So that means that turns everything here to 1 times sine squared b. And that should give me sine squared b. Okay, so my numerator, the terms in the bracket are the same. So I will now have the root of 1 plus cos b, then 1 plus cos b, all divided by, now from the same identity, sine squared b plus cos squared b, we know that sine squared b plus cos squared b is equal to 1. Because I'm working in terms of cos, I want to replace this, my sine squared b, with an identity in cos. So my sine squared b will now be equal to 1 minus cos squared b. So this now becomes 1 minus cos squared b. Okay, now 1 plus cos squared b and 1 plus cos squared, when I multiply this, if they were variables, if I equate this to a, this would have been a times a, which would give me a squared. So this now becomes the root of, this will give me the root of 1 plus cos b squared all over. Now this identity, 1 minus cos squared b can be written as 1 squared minus cos squared b. And this becomes a difference of 2 squares. So this can be written as 1 plus cos b, 1 minus cos b. So in place of this, I'm going to write 1 plus cos b, 1 minus cos b. All right, the square root of this will give me 1 plus cos b. So divided by 1 plus cos b, 1 minus cos b. 1 plus cos b will cancel 1 plus cos b, and that will be equal to 1 over 1 minus cos b, as required by the question. So we have been able to show that this expression is equal to 1 over 1 minus cos b, as we have shown here. Thank you.